So we are still working on finding the zeros of polynomial functions. So we're working on example 2. Like in example 1, we're going to call the left side of the equation f of x. We're looking to solve f of x equals 0. So if you don't have it already, please pause the video now. Make sure that you have this function entered into the y equals on your graphing calculator. So again, pause if you don't and restart the video when you do. So we have this entered. My best practice is, I'm going to put this to the side for a second. I'm going to find my PRZs. So my PRZs are going to be plus or minus the factors of my constant. So that's 1, 3, and 9. And the factors of my leading coefficient, that's 1 and 2. For a lot of you, I think it'll help to do these all out. So 1 divided by 1 is 1. 3 divided by 1 is 3. 9 divided by 1 is 9. And then we also have 1 divided by 2 is 1/2. 3 divided by 2 is 3/2. And 9 divided by 2 is 9/2. Okay, I also think it might help some of you to think about what this is as a mixed number or a decimal. So 3 over 2 is 1.5. I'm going to write that as the decimal 1.5. And 9 over 2 is 4.5, which I'm going to rewrite as the decimal 4.5. So again, you don't need to do this if you don't need to, but if that helps you, you're writing things out to help your memory. Okay, so looking at this, my largest number is 9. So what I'm going to do is I'm going to go into my graphing calculator. I have my function plugged in. I'm making sure all of my exponents and signs are correct because that's my biggest mistake. I'm going to my window. And since this would go from -9 to 9, I think keeping this at -10 to 10 is fine. And generally, I keep my y min and my y max between -1 and 1, because again, I'm just looking at what's happening around the x-axis. So the next thing that I'm going to do is I'm going to hit my graph. Okay, and I can see that this crosses in 4 different places. And that makes sense that my graph might have 4 intercepts because my highest degree is 4. So looking at this, I'm going to try to get a little closer picture because it looks like I could go from, let's say, 1, 2, 3, 4, -5 to 5. So again, this is sort of trial and error. If you don't need to do this step, that's okay, but I often do. So I'm going to do -5 to 5. And I'm going to look at my graph again. So this just gives me a little bit better picture. So it looks to me like this is -1, -2, -3, -3 and something. And I don't have a possible rational zero that's -3 and something. So that tells me that this is going to be one of my irrational solutions. My next one, it looks like it's between 0 and 1. So my -1/2, I'm going to put that as a possible, x equals -1/2. The next one, to me, it looks like it's a little further than 1/2, but I am going to check x equals 1/2 just in case. And the last one, 1, 2, 3, to me, this looks like x equals 3. So I want to check and see if those are indeed zeros. So the way that I do that is I'm going to hit my second function in my table set. And I'm going to make sure, it doesn't really matter what you start with. Maybe I'll start with negative. Actually, I want to start with integers. It really doesn't matter what you start with. I'm just going to keep it at negative 10. But you do want to make sure that that ask is highlighted. Okay, so now I'm going to hit second graph, so I get to my table. Some values are already in there, but you want to type in these values. So I'm going to clear. Sorry. So we'll figure out how to clear it some other day. I'm going to type in negative 0.5 and I get a 0. So that is a root. So I'm going to circle it on my paper. Then when I type in 0.5, I get 6.25. So that shows me that's not a root. So I'm just going to cross it out. And then my next one is 3. I do have a 0. So that shows me that's a 0 as well. So now I need to find my other zeros. So I know that these are my only rational zeros. So now I need to find my irrational zeros. The way that I'm going to do that is synthetic division. So I'm going to choose my 3 first. This is my root. It's not a factor. So your 3 just goes into the box. Your coefficients here are 2, 1, negative 24, 6, and 9. Okay, so I am going to complete this synthetic division, and then I'm going to do repeated synthetic division with negative 1/2. So pause the video now, do your repeated synthetic division, and restart the video when you're ready. Okay, so I did my synthetic division with 3, came out with a 0 at the end. That was a good sign. Then I did my synthetic division with negative 1/2, came out with a 0 at the end. So again, hopefully from the work that we did last week with our synthetic division with fractions, you realize you can pull out a 2 here. So if we pull, so actually I'm going to write this as 2x squared plus 3x minus 3. Okay, and then the other factors are going to be x minus 3 and the x plus 1/2. Okay, and that 2 times the x plus 1/2 would give us a factor of 2x plus 1. We don't have to write out that factor, but sort of now we have this factor with smaller numbers, which makes life easier for us. So we know that those roots are irrational. So right away, we know we're not going to be able to factor this. This is going to be prime. Okay, we don't have two numbers that multiply to negative 3 and add to 3. Okay, so our choice is to use the quadratic formula. So everyone take a second right now, pause the video, and complete the quadratic formula. Okay, so when substituting in, I got negative 3 plus or minus square root of 21 over 2. If you did not get that, pause the recording, look at my math, find out where you made your mistake. So we can check this on our calculator. So you can actually type in, you have to be careful with order of operations. You have this entire numerator divided by 2. So I'm going to put parenthesis, negative 3 plus the square root of 21. Then I'm going to close the parenthesis. So that gives me my numerator. The whole thing is divided by 2. If you don't put in the parentheses, you're not going to get the right answer. So this does a couple of things nice in one spot. One, it gives us the decimal approximation. Okay, so most of the time we're going to be looking for decimal approximation to 2 decimal places. So my exact answer is x equals negative 3 plus square root of 21 over 2. And my approximation, oops, sorry about that. So my exact answer is x equals -3 plus square root of 21 over 2, and my approximation is going to be 0.79. Okay, and I see that I do have a 0 there, so I know I have the correct 0. Okay, and then I also want to plug in, oh, I forgot my parenthesis, -3 minus the square root of 21 divided by 2. Okay, so this one is kind of interesting. -7 e to the -12th, that's scientific notation. Okay, this is a number because of that e to the -12th that is super, super close to 0. Okay, this is a rounding error on your calculator, and you need to realize that a number like this with a really large negative exponent is really, really close to 0. So this is evidence that this is also a 0. Okay, so I'm going to write that down real quick, and then I want us to look at the graph. So again, my exact answer would be 3 minus the square root of 21 over 2, -3 minus the square root of 21 over 2. I'm fine with you keeping it like this in your list, but I think it's sort of easier to see that this is our -3.79. Okay, and again, I'm getting that approximation from right here. Okay, saving myself sort of a step of writing it out somewhere else in the calculator. And then my rational solutions were x equals -1/2 and x equals 3. Okay, so here are my exact values, and here are my rounded. You could put this as a decimal, sort of for consistency. Okay, looking back at this, if I look at my graph, let's see if all of these make sense. So I have one, sorry, making people car sick, that's -3.79. Okay, so -1, -2, -3, pretty close to -4. It seems to me that it's reasonable that that would be -3.79. -1/2 was right here. 3 was right here. And then our 0.79, okay, pretty close to 1, also seems pretty reasonable for our zeros. Okay, so again, watch this video again if you need to. Work with your classmates, but try the problems, work until the end of class. Okay, I'm guessing that you should have about 40 minutes in class, 30, 40 minutes in class, and then you want to work for another 45 minutes outside of class. And we can go over this again when I'm back in class as well.